Hi, this is Dr. Shesha from AC Department, SNS College of Technology. Here we are going to see a topic named Building a Responsive Audio Clipping System using Operational Amplifier and Diodes. So here we are going to see a simple and useful electronic circuit named Audio Clipping System, which is using the components of Operational Amplifier and Diodes in order to cut the unwanted high voltages. Here, my students are going to discuss what is the circuit we build and what is the effectiveness we got as a result.
Hello all. So let us take some electronic device like microphone or music play music. So when we speak into the microphone or play music, the sound signal may get too louder. So when we get too louder, the electronic circuits will get damaged and it creates some high voltage spikes. So it must not happen in the electronic device. To reduce that high voltage spike, we are using these circuits and we are designing an audio clipping circuit to avoid these high spike voltages.
Hi guys, I'm going to tell about how the clipping is working and what is clipping and how they are working in the circuit. So clipping is nothing but it is cut down the signal of bottom and top layer of the signal, which follows the set limit. So for these things we need an amplifier which will send the signal to source. And we are using two Zener diodes which is placed opposite together and cut down the voltages, the extra voltages. So if the voltage is normal and the input is normal, the output is also normal. If the input is goes more than the limit, the output voltage is very extreme. So in that time, the two Zener diodes will cut the voltages and clipping is happening.
Okay, when we talk about how these circuits are designed, let me explain the circuit diagram later. Basically, the sine wave is given as an input, basically in the form of audio signal. And two linear waves are used, the action it is placed in the passive as opposite direction, and we are using a buffer or buffer. It is like we are using it because to pass the signal without any change to get it. So, but basically, why we use this because like to not exceed any certain voltages, like should not exceed any voltages. The basic the certain level of the voltage is plus or minus 5 volts. So if any voltage is more than this, or we basically get cut off. We also tested it using the simulation MOSFET multi-cell, and we got to see that the more than the 5 voltage of the signal amplifier will be clipped.
Okay, hello everyone. Thank you, and I would like to explain about applications and what we learned based on your topics. So first, when we talk about applications, as Sujana said, using this circuit, we can use this in three cases. In first case, which is a microphone input circuit. So in that circuit, as Sagarita said, there is an issue, right? So that issue can be sorted by this circuit. And the second way, we can use in audio sampling devices, and also in the last case, we can use in signal processing also, which is very useful in embedded systems. So what I learned from this was, we can learn how an op-amp can be used with the diode, and which is useful for the upcoming electronic devices. And also we can use simple components, and we can build many circuits which will reduce the complexity of the circuitry. And through this circuits, we can test and simulate the op-amps circuits, which will be more efficient for electronic setup.
Okay, as a conclusion, our students have built the circuit with operational amplifier, and we are also using the precision diodes, which provide a better result in the form of audio clipping system that cuts or clips the unwanted signals, which are very useful in headphones and audio systems, speakers, etc. Okay, thank you for joining in this video. Thank you all.
Thank you.
We can join in the next video.